This video is produced for the students enrolled in Diesel Engineering 2 simulation course held at Cal Maritime. The contents will cover all the steps necessary to successfully complete Lesson 5, the Computer PTT exercise. Now, just for mentally being able to envision this exercise, we're starting at a shipyard in Ulsan, Korea, and the ship has gone through an extensive shipyard. I've actually put a depiction of the harbor there, and you can see that this leaving the harbor would actually be a very short departure period, similar to what we're doing in this exercise. In this exercise, the engine is rolling over on the turning gear and has already been prepared for departure, and then we are going to maneuver the engine out and take departure within this exercise itself. Now, one of the limitations I have in that my computer does not have a separate graphics card, and while I can do the video capture and run the Kongsberg engine simulation program, I'm not able to run the virtual reality in addition to that, because my computer will slow down or really pretty much stop. So within this video, I'm strictly going to be going through the pages as depicted in process and panel directories. I will not be able to do the VR. This is also acceptable for you when you are in the PTT testing phase of the course, but just realize that within the full mission, your group will be expected to use the virtual reality, and in addition, you will be actually required to maneuver the engine out at the engine side. Now, on that, Kongsberg has done a very good job of simulating the local control stand on a Burmeister Wain MC engine. On the left, you will see their graphic representation, and then the drawing on your right, that is taken out of a technical manual from Burmeister Wain on what the local control station should look like. Now, what you're looking at on the top of the control stand, those are all the pneumatic controls to operate this engine from local. But in addition, on the side, you have a mechanical clutch. Now, this mechanical clutch serves to disengage the fuel racks from the governor and connect it to a wheel on the local control stand, and vice versa. As you start this exercise, realize that you are clutched in to the local control stand so that you will operate the fuel rack locally using this wheel. But when the bridge requires for you to transfer to bridge control, you will have to shift this by moving this wheel, and that will shift that clutch over to disengage from the control wheel for the rack, shift it from the local, shift it to the governor, which is controlled by either the EOS or bridge throttles. Now, that's the mechanical side, but on the pneumatic side, you also have a switch here on the local control stand. That pneumatic switch will switch the pneumatic controls from, in this case, they're listing it as emergency to remote. All right. At this point, let's go ahead and get into the how to run this simulation. Now, or this exercise, simulation exercise. One of the things I want to point out is that you are constrained in the beginning to a very set series of events or actions that you have to take to be successful. Be very careful in this beginning that you take each one of those steps And then you will go through with testing the main engine on air, testing it locally at the to fire at the control stand, and then you will switch to bridge control. Once you switch to bridge control, they will maneuver the engine out, and your role then shifts in the mid part of this exercise to monitoring the engine and its operations. And then once you are near departure, then your role is going to now shift again, where what you are doing is getting the ship ready for departure and shifting over your electrical loads to the steam turbine generator and the main engine shaft generator. But be very careful in the beginning that you very exactly follow the instructions and that you do not make any mistakes, because if you do, it will affect your success rate on this. All right, so let's go ahead and start in. I'm going to hit F1 and start the simulation. We are going to put heat on the oily water separator. In today's world, you would have to be approximately 15 miles offshore to use the OWS to pump over the side. So we are not going to do that, but we are going to prepare the oily water separator for operation so that after departure it'll be ready to put in service. Just realize on this is all we're doing is heating the water within the separator tank to make sure the fuel in that water is fluid enough to be treated properly. Next, we're going to go to the shaft generator. We're going to put air to the air clutch. We have to switch control to local so we can clutch it in. Once it clutches in, then we're going to go to remote and we're going to put on our auxiliary power. We have to wait till we get a ready light. Once we have that ready light, then we can start the pony motor on the synchronous condenser and make sure that you see the RPM coming up. Next, we'll get the voltage control on, so we're going to go to shaft generator. This run light flashing, that you want to look for that because that's that synchronous condenser coming up to speed. Put your excitation or voltage control on. I like to input about 52%. It seems to work well. Now that is ready to go. The bridge has told us that we are very close to being ready to test the main engine on air. So the first thing we're going to do in preparation for that is go to local control. We are going to stop the turning gear, disengage it, and put the auxiliary blower in automatic. There's two blowers themselves. Now we are waiting for the bridge to give us permission to roll the engine over on air. Realize with this, these messages you get from the bridge have to be followed exactly. If you preemptively do them without bridge permission, the same thing that would happen in real life will happen with this exercise. You will fail it, right? You have to wait for instructions from the bridge. Now let's go to the start air. The captain's going to want 2 bottles on the line for maneuvering. We're going to put air to the main engine. We're going to go to the pneumatic control system and open up the 3 blocks. Then we're going to go to local control, and we got to make sure that our fuel rack is all the way down and we're in the head position. We're going to hit start and we're waiting for the RPMs to come up. Once the RPMs come up, release it, and you can see that they came up here. And then we'll wait till it stops. We're going to go hit the astern and roll it again. Be very careful that you see the RPMs going up into the tended direction. It's not unusual. Look, it did it. See how it went in the wrong direction? Let it stop, try again. Now it rolled in the right direction. Also, you're watching to make sure that your fuel pump followers shift position. So now we have The captain has said that our air pre-test is good. Watch for that. If you don't happen to get it right away like we just did, it means that you may want to roll it over again in both directions until you get that indicator. So that being done, the first thing we're going to do is going over to the ventilation system. You can see we're a little bit of a vacuum. We actually would rather have, at this point, a little bit of a positive pressure on the engine room. And especially since we're getting underway, and your biggest exhaust fan, of course, is your turbochargers. And then we're going to go to process directory, and one at a time we're going to close each one of these indicator cocks. Make sure you get them all. If you leave one open, you'll actually cause the fire alarm to go off because of the gases being spewed into the engine room when the engine fires. Then we will go back to local control, and we're going to wait for the permission from the bridge for standby and stop. There, okay, we're getting standby stop. There's our stop. We'll go ahead and then on the standby, we actually have to go to main engine control and answer it there, the EOS. All right, so we have a stop bell. I'm going to get ready for that. There's our dead slow. Okay, so I'm going to move my rack up about 25%. And then I am in a stern. Make sure you're in the right direction. That's a stern. We're going to stern. Hit start. Watch your RPMs. As soon as it comes up, release. And we'll watch our RPMs. It's a little bit low, so we're going to bring this up. And you have to adjust your rack to get to the proper. All right, now we got a stop bell. So I hit stop, and to press the stop button, you don't have to drop the fuel off. It's not necessary. You're activating your puncture valves. Wait till it stops. Then I'm going to put back to my start position. Now I've got a dead slow ahead. Move ahead. Again, be very careful as you roll this engine over that you are observing the direction that it's, and it did, so I'll release. We've started in the head. We've got our fuel pump followers showing correctly. Let's move our rack up a little bit. Okay, now we're getting a stop bell. Go ahead and stop the main engine. Okay, so the bridge is now requesting bridge control. One thing that's very important before you move any farther from this is go ahead and bring the rack down all the way to 0, because you are having to mechanically transfer this over, and the rack has to match the one in the EOS, where that computer throttle will be at 0. Then we're going to go to the maneuvering system and put it in this panel, put it in remote. We also want to check on the control system that has also shifted to remote. Then we're going to go to the main engine control, and we are on EOS, engine control. Bridge is requesting bridge control. So at this time we'll shift that. Okay, now the captain is requesting power on the bow thruster. To accomplish this, first go to the generator control and put it in alert mode. Now, what's going on here is that bow thruster will pull quite a bit of power, and once it starts doing, as soon as the power management system thinks that it needs another generator, it will start diesel generator 2. Alert mode is an indication to it that once it starts a generator, it will not shut it down. So that will keep all 3 generators on the line while we're maneuvering with the bow thruster. even though at individual points of time, only 2 would be required. So this alert mode is specifically for use with the bow thruster, because the bow thruster is a very large electrical motor with a large amount of load. Now, if you want to watch what the captain's doing a little bit, we can go to course control. Oh, excuse me. We still have not given him power. I'm sorry, I started talking. We need to give him power on the bow thruster on the starters page. Otherwise, he's going to get quite irritated at us. And then we can go back to course control. So he still hasn't put that on yet. So let's go over and look at what's going on here. So we still not have any commands yet. Nope, there we did. We just got in the stern. All right, so he is starting the main engine in the stern. Now, very important too on this is we should be looking at our control system and this mimic. This tells us that we're on bridge control, we are going astern, that our fuel pump followers have shifted, and that the engine is actually firing. This would give you the start is when start air is on, the fuel off, that's when your puncture valves are activated. Whenever they're getting ready to start and stop an engine, you should be looking at this, and then these are your permissives for slowdowns and shutdowns. Let's go back to course control. All right, the bow thruster is on, and we have a pitch setting of about mid-pitch, and so we are pulling electrical load. We can also see that the rudder is hard over, which is going to add to the torque to the main engine. So let's go back and see what our generator control, if it's okay. Yes, it is, and it has the 3 generators on the line. All right, so 3 generators are now on the line, and they will stay on the line even when the power consumption drops off. Now, we should be monitoring the main engine, and a good place to do this is the indicator panel. The Auto Chief indicator panel gives you a bunch of different things. One, it's telling us what our RPM, so we're at a dead slow. It actually gives you the speed of the ship, which is nice because that does affect the torque on the engine when you go from change speeds. Then the other thing that I think is really important is we have our fuel oil pressure at the inlet to the engine. We're currently about 8 bar. Fuel oil temp to the main engine is 120, and our viscosity is in good shape. But the biggest one is watching your turbochargers. Turbochargers are a good indicator of load. So you can see the load coming up here, and you can also exhaust gas temperatures, and they've risen considerably. We're under some load here. Even though we're really only doing right now 38 RPM, so that's a really slow astern. Some other things too is you do want to keep an eye on your boiler and your steam pressure and the level. This gives you an indicator. Again, we're still hard over on the rudder. That's what's adding to the load. And you notice we're already now up to about 4,000 RPM. Another screen that's very helpful on this is to go to the turbocharger system, and then it gives us an indication again of our individual exhaust temps, RPMs on the turbochargers, what our boost pressures are, because boost pressures are also very important. So we're about 0.6 bar boost. So another way to say that is 0.6 bar would probably be about 8 psi boost, which is a lot of boost. Now you notice too our auxiliary blowers have already cycled off. Now something's happened, so let's go back and look at our indicator panel. Okay, we've stopped, so they're going to be switching on the engine and restarting. So I'm going to go back to control system. Your puncture valve, you are stop. Your puncture valve is active, no fuel delivery, and right now your followers are in the astern position. This also shows you engine stopped, and you'll notice when it shifts, you'll see a starting, waiting for ignition. Okay. So we're starting. The start air is on. The puncture valve just released. And it has shown that the engine is running. Okay. Let's go back. All right. So we're doing a little bit over dead slow. Looks like we're settling out to dead slow. Loads are low. Exhaust temperature's high and it's dropping down. The other one on that, by the way, is watch your smoke indicator. The smoke is another indicator of load. But you can notice that when that engine started, that exhaust temp rose suddenly. Let's go check our generators. Our generator loads is very reasonable. We should also be looking at our main bearings, especially as this engine starts to speed up, to make sure that our bearing temperatures are fairly similar and you don't have one rising, indicating that you may have an overheated bearing. Okay. Let's see what he's doing with the bow thruster. The bow thruster is on, but it's idle right now with 0 pitch. And your rudder is now mid position. Let's go look at our speed and our loads. So we're coming up on load a little bit. Exhaust gas temps is quite low, in good shape. The engine is in the ahead position, again a dead slow. We're basically stopped in the water right now. It has taken off the astern headway and we start moving ahead pretty quick. Again, take a look at my fuel system. I'm a little bit always concerned that our viscosity stays in proper while we're doing this, because this is a pretty sudden changes. I'm also going to look at the generators to make sure that they are all operating properly. You notice, by the way, that number 1 generator is on distillate. Number 2 is on heavy. Everything looks good there. And the steam turbine is being supplied steam off the oil-fired boiler. So that gives me 3 different fuel sources for the electrical generation. The worst thing is to lose propulsion and power. Right? I've got a pretty good chance that I'm not going to be able, or I will not experience a power blackout. I've done everything I can to prevent that. Okay, so we're coming up in RPM. At this point, we're at 38, and 38 is slow ahead. On this panel too, you can see the fuel rack. And right now, it looks like you're a little bit under 40%. Our load limits and thermal load program are not on. The computer, when you're on bridge control or EOS control, engine control room, the computer will be looking at the load being imported onto the main engine from during this maneuvering and will limit the fuel rack to prevent an overload situation. Typically, the thermal load program is more from when you're going from your maneuvering speeds up to full C speed to allow the engine time to warm up. You also on the limits for these two, you have a torque limitation, which, by the way, this comes up with the torque limitation. That light would, if we hit that, comes on. But we also have a scavenging air limitation. In other words, to prevent the engine from burning black because you do not have enough air supply until your turbochargers spool up, it will limit the fuel rack until the turbochargers are supplying sufficient air for good combustion. Let's go back to our indicator panel. So again, viscosity is good, temperature is good. We're coming up in the load. We're 4,500 RPM on load. Exhaust temps look very, very good. Our main engine, the jacket water on the outlet is up to 80, so we're in good shape there. That's normal. Lube oil pressure is good. All right, so the bridge is done with the bow thruster. To secure this, we're going to go ahead and leave the power management system in alert. So all we're really going to do is come over here and take out the power, disconnect the power from the bow thruster. And I really kind of should have come up and checked first. You want to make sure that the captain has actually stopped the bow thruster before you open the breaker. And you can do that here, or you can do that right at the starters panel by making sure that this is showing 0 kW before you open it. Either way is acceptable. Now, okay, so the vessel has cleared the harbor, and we can now start the evaporator. So we'll go to the freshwater generator. Just remember that harbor water does typically contain some dangerous pathogens, and the heating in an evaporator does not kill that bacterial load. So you never really want to run the evaporator in port. If you do, then you have to sterilize the water using chlorine after you've done that. So anyway, don't forget to close the drain on the evap, line up the suction to the feed pump, the discharge from the feed pump, the overboard from the adductors, and go ahead and start your feed pump up. Then close your vacuum breaker valve, and we're going to have to wait until this pressure gets down to 0.5 bar absolute, or half atmosphere. And the very important thing to remember on here, see how I have no flow right now for the salt water to the distillate condenser? Come over here and open the root valve and go back and make sure that you have a flow. This is a common reason for the students to fail the assessment, because putting this evaps on is a critical achievement, is because they do not put the cooling water to the salt water to the distillate condenser. Now technically we need to wait for this to come down and clear the alarm and get down below 0.5 before we switch over. So the bridge is actually getting close to departure. Now, one of the things I'm going to point out right here, I would be worried about this as a heat sink on my jacket water, except for the fact that this has a temperature controller that will bypass the water around the evap if it starts dropping the jacket water to the main engine below 79 degrees. So that is to allow the evaporator to be used when the engine's running at less than full speed. So we'll wait for that. Now, the other thing is once I put heat on, then I have to wait for there to be water in the distillate condenser to start the distillate pump. What tends to happen if you start this up with this dry and under a vacuum, you'll tend to airbound that pump and it will not pump the water afterwards. You normally do want to wait for water to build up. You do the same exact thing on the Bear. It's just there's a little sight glass that you look for a half full, and then you start up the distillate pump. We're good on the vacuum, so I'm going to open the jacket water and go up to 25%. So they're getting ready to, we're still making a good RPM, but they are getting ready to drop off the pilot. Oh, it looks like they're stopping the main engine now. Let's take a look. Let's go to engine control. Yes, the main engine has been shut down. It has an RPM, so they are dropping off the pilot. So at this point, I'm going to start switching over the generators. Now, I'm going to put take all three out of automatic. I'm going to take out the permissives and the alert mode. And the first thing I'm going to do is on the turbo generator is take it off the line. Now, it's difficult for me to show you both screens, but on my other screen I'm putting diesel generator 2. We're going to be getting departure soon, so good. This is a good time to be doing this. And these governors now this year have been redone, so they're kind of slow, and unfortunately you have to run them a long time. They're much slower than they were before. But on the diesel generator number 2, I'm going to put the governor to the increase, and I'm going to wait till this hits 60 hertz, and then I'm going to put this to decrease. And what I'm doing is I'm shifting load right now from the turbo generator over to number 2 generator. So right now number 1 and number 2 are going to be taking the load. Now this is coming up, so I'm going to cycle off the increase for a second until this drops back down while I'm decreasing. So I'm controlling frequency. On number 2, now I'm putting it back in, so it's increasing and taking more load, and I'm transferring load from the TG over to number 2. This is much slower than it used to be. It used to be you would click on these. Now, unfortunately, you have to kind of run them. Okay, and I want that to come up, so I'm going to take that off for just a second. And that load will continue to drop because I'm increasing number 2. Okay, and that's going to be close enough. And I'm going to disconnect it. Now, I'm going to go back to number 2, and I'll bring it up on this page. So we've transferred quite a bit of load over to it. We're still in good shape. So the turbo generator's offline. Now, these alarms that we're getting, these are because they stopped the main engine, and it has actually stopped. And that is mechanical cylinder lube oil pumps, the Hans Jensen. So yes, there is no flow when the engine stopped. That is normal. And we're going to wait for them to restart this engine. So I'm going to go to process directory, and I'm going to go to the control system. And we'll wait for them to restart. Now, one thing on this is I'm not going to transfer the TG over to the exhaust gas boiler from the oil-fired boiler until they've started this main engine and they start bringing up the RPMs. Now, what's going on is the ship would have been moving at too high a speed. In fact, we could take a look. If we go to indicator panel, ship speed was over 5 knots. So they shut down the main engine to drop the engine speed down so that, whoops, we just had a start, so the engine is started. All right, let's check. So yes, we're coming up. So now we can switch over the steam turbine generator. wait until they restart it, because otherwise you just don't have the energy, and it actually makes your life a little more difficult. So we're ready to switch over. What we're going to do is we are going to shut down the steam to the steam turbine. We are going to shut the superheated steam stop at the oil-fired boiler. We are going to open the drain and shift over to the exhaust gas boiler. Okay. Now, while we're doing that, while that's happening, then we are going to go over to the boiler combustion. And I like to drop this down to 6 bar. This prevents, once this boiler is cycled off, this helps prevent it coming back on unnecessarily. And I'm waiting for the steam temperature to come up. And you can see it's coming up now. Okay, we're still really at dead slow. So we still don't have a lot of Yep, our steam temperature is low. That's again why I suggested that you wait till the engine start. Okay, our dampers are open. But again, that energy for that exhaust gas boiler is coming off, and we're still really at dead slow. So not a lot of energy available right now. And what I am doing during this shift from the oil-fired boiler to the exhaust gas boiler, I would be worried about hitting the turbine with water, because that exhaust gas boiler has not been on for a while, and there could be water in the superheated steam lines. So I am basically making sure that this superheater is up to temperature, and I've thoroughly drained the steam going to the TG. All right, we're going to be switching over to standby on bridge control. To answer the standby, we're going to be going over to main engine control, and it'll show up here. We'll just go back and forth and keep checking. You have 2 screens, so you can be watching. There it is. So we now have departure. Load's coming up. So we're starting to get some load on it. See your turbocharger spooling up. Now we're ready to go. Okay, I'm satisfied now that we should be in good shape. Our temperature's coming up. Temperature's good. We can bring this up pretty quickly because it's already hot. It's spinning right now. It was 2,000 RPM, and we're just going to bring it right back up. I'm satisfied that we thoroughly drained this line. And what I'm doing too is I'm waiting. See how this governor is wide open? I'm waiting for that governor to start closing. And then once it is closing down, then I know I'm up to speed, and I can just bring it right up to 100%. We're close. Governor's shut down. I'm just going to go to 100%. Close my drain. Now, we're going to transfer that load back from number 2 to the turbo generator. So I hit the synchroscope, turbo generator. We can check here. We're pretty close to bus frequency, or very similar. Again, this is much slower than it was. It's a little irritating. The governor is so slow, but I'm going to go in the increase. You can still see how slow. Come on, we have to go slightly faster, and we want our voltage to be slightly higher, 2 to 5 volts. Okay, we'll connect that up. So we're on the line. We picked up some load. I'm going to take on number 2. I'm going to decrease it a little bit and transfer some load over. So, well, I can show you that actually. It's not that big a deal. Diesel generator 2. So I'm going to decrease and get our frequency, and that'll transfer some load. So we want to keep 60 hertz. That's close enough. And that's good enough for right now. We don't have a lot of energy. You know, the engine's still coming up to speed. So once that's done, now what I'm going to do is I'm going to transfer the load from diesel generator number 2. On my other screen, I'm bringing up diesel generator number 1. Actually, I'm going to change that. Why not take number 1 off? So we'll go to number 1. The load's less. It'll come off faster. And my other screen will bring up diesel generator number 2. And I'm going to transfer load over and secure this generator. So I'm going to go decrease. And I'm going to wait until we hit 60 hertz. And then I'm going to start increase on number 2. And I'm going to transfer that load off. That's close. We have about 5 minutes. All right, and I'm going to disconnect number 1. So now we have 2 generators on the line. We have number 2 and the turbo, and I'm going to put the shaft generator on. So we'll go to shaft generator, synchroscope, switch over to shaft generator. We're good on the voltage. So a little bit on frequency. By the way, these green lights tell you when the computer feels that you're in range. So we got a green light on voltage and frequency, but that's still awfully slow. I'm not happy with the governor control, whatever they did to it. All right. All right, so now we're shaft generators on the line. We're pulling current. And I'm going to go to number 2, and I'm going to decrease. I forgot. No, I'm sorry. Now I'm going to, there's 2 things I've forgotten, so we'll get those real quick. On the freshwater generator, I forgot. I let the level get high. Put your in auto. The other thing, we're coming up to speed. Let's go to our ventilation system. You see we're starting to get into a vacuum. We'll go ahead and shut off 2 of your exhaust fans. All right. So I'm going to take number 2 off. So we're shifting power over to the shaft generator. I just took decrease off number 2 to get that. Now put it back on. We're down to about 320 kW on number 2. Shaft generator can take as much load. It can take the entire plant load by itself. So I'm not worried at all about overloading it. I'm down to 120 on number 2. 80. About ready. All right, I'm at 30 over here, so I'm gonna disconnect number 2. All right, panel directory, generator control. So now we've got all the load on these two. We're going to go priority 1 on the shaft generator, priority 2 on number 1, priority 3 on number 2. I'm going to curtail the cool down, so I'm going to go ahead and stop both of these. I want to check the boiler. My boiler has cycled off, so I'm in good shape there. Okay, so I am going to put it in optimal mode. This is a DG2 pressure. That's just a nuisance alarm. And let's go ahead and put all of these in auto. All right. So now we have it where we have the power on the turbo generator and the shaft generator. We are combined cycle. So this is strictly burnt using waste heat. The optimal load is designed the automation so that it will control boiler pressure. Since this is waste heat, right? That boiler is cycled off. There is no fire. That the heat for the boiler is coming specifically through the circ pump to your evaporator tubes on the waste heat boiler and back into the steam drum. So this boiler is being fired solely off of waste heat from the main engine. So this is a combined cycle and we are utilizing waste heat. Optimal mode is supposed to automatically control the load on the turbo generator so that it will control the pressure at a reasonable amount. So we're within 1 minute. We're going to go ahead and halt it. I'm hitting F2. I'll bring this over so you can see that even with my forgetting a little bit, usually you actually don't wait too long to. As soon as I get departure or the engine restarts, I typically put the ventilation, cut off a couple fans, exhaust fans, and I keep an eye on my second screen. I leave one screen so I can keep an eye on the evaporator, and when it gets a quarter to, the distillate condenser gets a quarter to half full. So you have to successfully roll the main engine over on air, successfully test the main engine on fuel, and transfer control of the bridge. Those are your critical achievements. Critical errors: do not roll the main engine without bridge permission. Make sure that you are pumping bilges over. You are not, pumping the bilges overboard, because that's an illegal act. So is rolling the main engine without the captain's permission, an illegal act. That you are not playing with the bridge controls and changing the throttle for your own goals, and that you are not trying to make the crew sick by starting up the salt water pump. So anyway, this is an outstanding, and I hope this has been informative, and I hope you've enjoyed it. Thank you very much.